To page 17, and we're going to do homework part 5. You should work out the homework first, and then you can watch the video to see the solutions. So let's look at number 1. We're given 2 single elements. They are separated by a plus sign. That's how we know they are 2 individual elements. And so this is going to be a synthesis reaction. So we'll put synthesis over here. Remember, this is going to be either synthesis or a decomposition. So first, let's translate these elements. Sodium is Na, then I'll put my plus, and chlorine is Cl, and then I'll draw my arrow. Now, you need to determine whether or not these are diatomics, because if it's a diatomic, it needs a subscript of 2. So if you look on your periodic table, sodium is here. It is not one of the 7 diatomics. And then here is chlorine. It is one of the 7 diatomics. So chlorine should have a subscript of 2. So we're going to put a little 2 there. Now, because it's a synthesis reaction, you're going to take one of each element and you're going to combine them on the right. Don't carry the subscript over to this side. So it's just going to be NaCl. Now, this isn't finished. You have to balance the charges on this compound. So I'm going to do that on a separate little paper. Go find the charges of each of these on the periodic table. So Na has a +1 charge, and Cl has a -1 charge. So we're going to write +1, -1. And when you have +1, -1, they cancel with each other. And so when they cancel, you're finished. So we're going to just leave it NaCl, and then that is completed. Now, you are also asked to balance the equation. That means we need to balance the coefficients in the equation. So we balance the subscripts first, and now we're going to do the coefficients. So I have 1 sodium on the left, 1 sodium on the right, 2 chlorines on the left because of that subscript of 2, but only 1 chlorine on the right. So to fix it, I'm going to put a coefficient of 2 here, and that's going to give me 2 sodiums and 2 chlorines. So now we have 2 chlorine, but I have modified sodium. So let me go back and fix it by putting a 2 here. Now we have 2 sodium, 2 sodium, 2 chlorine, 2 chlorine. So this is balanced with a 2:1:2 ratio. Number 2, we have aluminum plus bromine. So because these are single element plus single element, this is a synthesis reaction. So that means that they're going to combine. Let's translate this. Aluminum is Al plus bromine is Br, and then we'll draw the arrow. Individual elements need to be, you have to check to see if it's a diatomic. So here is aluminum, not a diatomic. Here is bromine in one of the 7. It is a diatomic, so it should be Br subscript of 2. So we're going to put a little 2 here. And now the product, you're going to take one of each of these and put them together. AlBr. Now, do not carry that 2 over to the right side. Now that we have figured out what our product is, we need to balance the charges. So don't forget, balance charges to get the subscripts. So I'm going to do this kind of on the side. AlBr. We're going to go look at the periodic table to find aluminum is here, +3, and Br is here, -1. So this is a +3, this is a -1. We're going to crisscross the charges. This will have a subscript of 1. This will have a subscript of 3. Of course, we don't write subscripts of 1, so it's just going to be AlBr3. So this should be written as AlBr3. Now that we have figured out our subscripts, we've got to balance the coefficients. So I'm going to put my little blanks in front. And now we have 1 aluminum on the left, 1 aluminum on the right, 2 bromines on the left, 3 bromines on the right. 2 times 3 is 6. That's my least common factor. So I'm going to make this a coefficient of 3 because 3 times 2 equals 6, and put a 2 there because 2 times 3 is 6. Notice I have altered my aluminum, so I need to go back and fix it, and so we'll have 2 aluminums. 3, 10, 2. Even though it's telling you that's Roman numeral of 2, it's still just 10. So we're going to put Sn plus phosphorus is P. And then we're going to draw our yield sign, even though they didn't provide it for us. These are our reactants. So because it's a single element plus another single element, this is a synthesis reaction. And so I need to determine, are either of these elements a diatomic? So I'm going to go look on my periodic table, and I'm going to see that here is tin. It is not one of my diatomics. And then here is phosphorus, and it is also not one of my diatomics. So they do not need a subscript of 2. I'm going to put them together to make my product. So it's going to be S, N, and P. Now we have to make sure that we balance the charges. You got to go get the subscripts from the charges. So I'm going to take this and do this on the side. Tin 2 is telling me that the charge of tin is +2, and then phosphide, if I go look on the periodic table, has a -3 charge. So we'll put a -3 here, and then we'll crisscross. This means put a subscript of 3 here, and this means put a subscript of 2 here. So it's SN3P2. So SN3P2. Notice I did all of that work on the side so that I don't make a big mess of my final answer. Now we're going to balance the coefficients in order to show the law of conservation of mass. So I'm going to put blanks in front of each element and compound, and that's going to be where I'm going to balance this equation. So we have 1 tin on the left, 3 tin on the right, so I'm going to put a coefficient of 3 here. We have 1 phosphorus on the left, 2 on the right, so I'm going to put a coefficient of 2 here. And so this would be the final answer, 3, 2, and 1. Number 4 is iron 2 and nitrogen. Again, at the moment, it doesn't matter that this is iron Roman numeral 2. We're just going to write Fe for iron plus N for nitrogen and draw our yield sign. This is an element plus an element, so this is a synthesis reaction. So I need to check to see if either of these are diatomic. So I go to my periodic table, and iron is not a diatomic, but nitrogen is one of my diatomics, so it should be written in subscript of 2. So I'm going to put a little 2 here. Because it's a synthesis, I'm going to combine these 2 elements, but I'm not going to carry this 2 over to the right side. So I'm just going to write F-E-N. And now I'm really done using the left-hand side. So now we need to make sure that for my product, we balance the charges and get the subscripts. So I rewrote FEN on something separate, and now let's go figure out our charges. They told us that it was iron Roman numeral 2, and that's how I know that this is Fe with a +2 charge. If I go look for nitride on the periodic table, that is going to be a -3 charge. So this is -3. So if I crisscross, this has a subscript of 3, this has a subscript of 2, so it's Fe3N2. So this is Fe3N2. And now that I've balanced my charges to get my subscript, I'm going to balance the coefficients. Put a blank in front of each, and let's figure out what are their coefficients. I have 1 iron on the left, 3 iron on the right, so I need a 3 here. I have 2 nitrogen on the left, 2 nitrogen on the right, so those are balanced. This will be 3, 1, and 1. Okay, number 5, we have magnesium and iodine. So since it's an element plus an element, again, we have a synthesis. Mg for magnesium plus I for iodine yields. Now, let's go see, are these diatomics? And I went ahead and highlighted the diatomics this time. So here you'll see magnesium is not a diatomic, but iodine is one of my diatomics. So I need a subscript of 2 next to the iodine. So now let's predict our product. I'm going to combine these 2 elements. So I'm just going to write Mg and I. Remember, this 2 does not carry over to the other side. So it's Mgi. And now I'm going to need to balance the charges so that I can get my subscripts for Mgi. So let's use the periodic table. I wrote Mgi somewhere else, and magnesium has a charge of +2, and iodide has a charge of -1. So we have +2 versus -1. we want to crisscross those. So this is going to give magnesium a subscript of 1, and that gives iodide a subscript of 2. Remember, we don't actually write subscripts of 1, so it's going to be MgI2, and so this is going to be MgI2, and now I've balanced my charges. Finally, we need to balance our coefficients, so I'm going to put a blank in front of each of these, and let's determine what the coefficients are. 1 magnesium on the left, 1 magnesium on the right, that's balanced. 2 iodines on the left, 2 iodines on the right. So this equation is balanced, and we have coefficients of 1 for everything. Number 6, we have manganese, Roman numeral 5. We don't need the Roman numeral at the moment, so we're going to just write manganese here plus sulfur and then yields. Now, are either one of these a diatomic? If you go look at your periodic table, manganese is not a diatomic and sulfur is not a diatomic. So this is an element plus an element, which makes it a synthesis reaction. So we're going to combine the two elements on the right hand side to create the product. So you're going to have MnS. Now, we're not done. We have to balance the charges. So we're going to balance the charges of MnS, and if you recall, manganese had a Roman numeral of 5. So that means this has a charge of plus 5, and then the sulfur, when I go look on the periodic table, has a charge of negative 2. We're going to crisscross the charges, and this is going to give us a 2 here and a 5 here. So it's going to be Mn2S5. So we have Mn2S5. And now we have to balance the coefficients. So we'll draw our blanks in front, and then we have 1 manganese on the left, 2 on the right, so that's going to put a 2 here. We have 1 sulfur on the left, 5 on the right, so that's going to put a 5 here, and now everything is balanced with a 2, 5, and 1 set of coefficients. 7, we have lead, 4, and fluorine. We don't need the Roman numeral right now, so lead is Pb and fluorine is F, and then I will draw my arrow. It's a single element plus a single element, which means this is a synthesis reaction. So now, are either one of these elements a diatomic? We'll go look here and see that lead is not, and fluorine is, so there needs to be a subscript of 2 on the fluorine. Now we're going to predict our product. We're just going to combine lead and fluorine, do not carry forward the 2, so it's just PbF. Now we're going to have to balance the subscripts of PbF. So here I wrote it on a separate little slip of paper, and lead has a Roman numeral of 4, so it's a plus 4. And then if we go look at fluoride on the periodic table, it's here. It has a negative 1 charge. So we'll put a negative 1 there. Now we'll crisscross. Subscript of 1, subscript of 4. Remember, we don't write 1s, so it's going to be PbF4, and so this will be PbF4. Finally, we want to balance the coefficients, and so I'm going to draw my blanks in front, here, here, and here. And on the left, we have 1 lead, 2 fluorine, 4 fluorine. To fix it, I want this to be equal to 4, so if I put a coefficient of 2, I'll have 2 times 2 is 4, which balances with those 4. And I have 1 lead still, 1 lead still, so my coefficients are 1, 2, and 1. Number 8 is potassium sulfide. See how there's no plus sign separating these two things? That makes this a compound, which means that this is a decomposition. So because this is a decomposition, it's going to be one compound that breaks apart into its 2 individual elements. So first I'm going to translate potassium sulfide. Potassium is K and sulfide is S, but it's a compound, so you have to balance the charges and go get the subscripts. I've rewritten it on a separate place, and now let's go find that potassium is a plus 1 and sulfide is a negative 2. So this is plus 1, negative 2. I'm going to crisscross. So this means I have a subscript of 2 here. This gives me a subscript of 1 here. We do not write subscripts of 1, so it's going to be K2S. So here it's K2S. Now we can put our yield sign. And to decompose something, you're going to break it apart into its individual elements. Don't carry this 2 over to the right side. It's just K plus S. Okay? And now we're going to go check, are either one of these a diatomic? And you'll notice here potassium is not a diatomic, and sulfur is also not a diatomic. So we do not need subscripts of 2. Finally, you need to make sure that you balance the coefficients. So I'm going to draw a blank in front of each of these. And now you have 2 potassium on the left, only 1 on the right. So we'll put a 2 here. 1 sulfur on the left, 1 on the right. So this is now balanced as 1, 2, and 1 for my coefficients.